Hello everyone. Waving hand, welcome to this brand new playlist on Spring MVC. In this first video, we'll learn the basics of Spring MVC, starting with what Spring MVC actually is, then we'll understand the Spring MVC diagram to see how it works, explore its advantages, go through some of the most useful annotations, and finally, check out the tools and technologies that are commonly used with it. From the next videos onward, we'll go step by step into practical coding, where we'll build a project and perform full CRUD operations using Spring MVC. So, stay tuned and let's get started with this exciting journey. What is Spring MVC? Spring MVC is a powerful Java framework that helps developers build scalable, flexible, and efficient web applications. It follows the model of UO controller design pattern, which separates application logic, user interface, and data handling. The model is responsible for holding the data and business logic of the application. The view is responsible for defining the user interface, like JSP pages, where the data is displayed to the users. The controller handles the user requests, processes them, and decides which view should be displayed to the user. Spring MVC is a part of the Spring framework that helps developers write clean, reusable, and maintainable code for web applications. Spring MVC works by taking a request from the browser, processing it through the controller in business logic, and then sending back the correct HTML page along with the required data. Now let's move on and understand the Spring MVC architecture with the help of its diagram. The user sends a request from the browser, for example by clicking a link or submitting a form. The request first goes to the dispatcher servlet, which acts as the front controller of Spring MVC. The dispatcher servlet then forwards the request to the controller. The controller handles the request and usually calls a service to perform business logic. The service layer uses the repository to interact with the database and fetch or store data. If there is new data, the repository stores it into the database. The repository then returns the requested data back to the service. The service passes the data back to the controller. The controller processes the data and prepares a response. It returns the data along with a view name to the dispatcher servlet. The dispatcher servlet uses the view resolver to match the view name with the actual JSP page. Finally, the JSP page is rendered with the data. The user receives the final HTML page in their browser. So, this is the complete request and response flow in Spring MVC. Now we see the advantages of Spring MVC. Spring MVC ensures a clear separation of concerns, keeping model, view, and controller independent for better maintainability. Loose coupling in Spring MVC makes applications easier to test and maintain. Spring MVC offers flexible view technology, supporting JSP, Timeleaf, and more for dynamic UI rendering. Annotation-based configuration reduces XML clutter, making code cleaner and easier to maintain. Powerful data binding and validation simplifies form handling and ensures data accuracy. Integrated with Spring features built-in support for security, AOP, and transactions. Next, let's look at MVC-specific annotations, which help us easily define controllers, map requests, and bind data between the model and view. The controller annotation marks a class as a Spring MVC controller. It handles HTTP requests and typically returns views to the client. The service annotation marks a class as a service component, which contains the business logic of the application. The repository annotation marks a class as a data access object, DAO, responsible for interacting with the database. The bean annotation declares a method that returns a Spring-managed bean, typically defined inside a configuration class. The request mapping annotation maps HTTP requests or URLs to specific controller classes or methods, enabling precise request handling. The component annotation is a generic way to mark a class as a Spring-managed component, allowing it to be automatically detected and registered in the Spring context. The @configuration annotation marks a class as a source of Spring Bean definitions, enabling Java-based configuration instead of XML. This annotation specifies the location of a .properties file, allowing Spring to load configuration values from it. Now let's look at the tools and technologies we use in this project, which help streamline development and ensure efficiency. We use NetBeans as our IDE for developing and managing the Spring MVC project efficiently. We use MySQL database to store and manage all the application data securely and efficiently. We use Apache Tomcat as the web server to run and deploy our Spring MVC project.